So this will lead us to our exploring data, okay? So I mentioned about the life cycle. So we actually will do the exploration here, which also usually data cleaning, which I think I mentioned this before. These first few sections, like data mining, but especially data cleaning, take up like easily 70% to 80% of your time as a data scientist. Basically because there's so many ways you can interpret, and you have to figure out what context it makes sense to actually clean your data, what you do with your dirty data, okay? Which this data exploration goes back and forth a little bit. This process, even though it's like the cycle where it looks like, oh, this is section 2, this is section 3, this is section 4, data science is much more fluid. You might be doing a little bit of exploration and then go back to data cleaning. You might even go all the way to predictive modeling and say, hey, you know what, I need more data. I need to go do some more data mining. Or say, oh, you know what, I need to check this out because the model's not doing what I'm supposed to. Let me explore this area again. So in the process, you'll go back and forth in different ways. But note this is the general idea of like how you would proceed forward, okay? So in this case, I kind of showed you guys, last time we read the data from a package, that library with sklearn. I'm actually getting the data from our CSV here, okay? So the Titanic.csv, this is just a file that's in here. It's actually the same one that is in the Learn curriculum. It's a really famous one because it actually came from Kaggle. Kaggle actually has this huge data set of basically things about the Titanic. So if we actually run this now, note that I also have NumPy imported as NP, so I use it for later. And you can see, I can see the first few things. So you can see the first few columns, basically just an unnamed column. This is probably just the index part of the file. These are things we could probably drop if we were looking at it. We have the passenger ID, so we can see, oh, it's about passengers in here. And we can see it survive 0 or 1. Usually 0 represents not, so like false. So this person didn't survive, this one did survive, this one just did survive. P class, you know, you might have to look and say, what exactly is that P class? Probably in this case means like what class of, like class in the ship there are, you know, high class, low class, you know, all that stuff. Could be something completely different, I don't know. That's where you have to like actually know what your data represents. Okay, and you can see name, sex, age, and so on. Okay, so you can see a bunch of different values. And one thing I want to point out right here is this guy, this MAN. Does anyone know what MAN would stand for? If you started section 3, you might know. But MAN, it's got a special kind of thing.
Like no value?
Yeah, null value. So if
not a number.
Yeah, not a number, so good. So in Python and Pandas, when we have a null value that Giovanna said, it's interpreted as NaN, which is, usually people say they NaN values, right? But not a number. And that's what basically Pandas represents it. And some of the reasons, there's a few reasons why we represent it as NaNs. They're universally used in Python data frames and NumPy arrays essentially, so we don't have to worry about saying, oh, was it a string? Was it something else? Was it a number? We can just say NaN, which is not a number. But just know that basically if it's a missing value, it's interpreted as NaN. Okay.
Yeah, no, I just want to confirm. That means there's no data for that person, for the cabin, for example.
That's exactly right, yeah. For this specific person, whatever this represents, there was no value for cabin.
Okay.
It's blank, yeah. Perfect. Okay, so this is a very quick thing, like just to see what head. Usually we'll see .head just to see what's in our data, just to see what it looks like. Say, okay, I can get the idea. Obviously not the full data set. So what we can do is do a df.info. And this actually gives us a lot of information about each part. So we can see really quickly, oh, there's 891 entries. Okay, cool. And then you can see that there's an index from 0 to 9 or 890. And then we can see, for example, okay, these are all the columns: unnamed, passenger ID, survived, P class, all the way through here. So you can see those are all the columns. And then we can actually see that this right here, this is the total number of non-null values. So all the non-missing numbers. So you can actually see there was some missing age here, right? Because there's 891 total. And for cabin, there's 204 that are not missed. So there's almost like over 600 that are missing completely, right? And on the right here, you can actually see what kind of type it is. In this case, it's an integer. So all these things are integers. Object usually means that there is some kind of, some string. That's usually how we define it in Pandas. So that means you can see really quickly like P class 31313, but it must mean something was weird. So we have to check that out and say, hey, this looks like it should be integer, but instead we're getting these objects. So maybe it's something else, right? And we can see float 64. Float number, do you guys recall what a float is? Float is just a decimal value essentially, right? And notice that 64 just represents saying how many bytes. So you can have more precision, a 64-bit integer or 64-bit float. So note that that's kind of like what it's saying right here. There are float 32s, but by default, we give it more information because usually you just want to have that available. And then that's the main stuff. So just note that objects usually mean that's interpreted as a string, okay? So this is a good, like, quick thing to see what the overall view looks like. We can also do something with df.describe, and df.describe looks a little prettier, I think, but it doesn't give you all the information. It's giving you more of the mathematical parts, which would say how many values there are, what the mean is, the standard deviation. We'll talk more about these things, and these, for example, these are quantiles. If you guys remember statistics, we'll go over it in the future, but they're minimum values and maximum values. So this is very useful to try to figure out, you know, like, oh, what's the spread of this? What does this data look like, right? This is part of the exploration before you start cleaning. Now, note, however, there are some missing columns in here. For example, the cabin column is not in here. And has anyone got an idea of why we don't have the cabin column in here? Like,
would that work only for like numbers?
That's right. So our describe only works for numbers. Okay. So yeah, so basically this is why describe doesn't show everything, but if it's basically all integer values or float values, we can do some calculations. For example, we can calculate the mean. Like, for example, if these are a bunch of strings, what is the mean name? That doesn't really mean anything, right? You can't have the mean, you can't have an average name. Like, that's not how this works, right? So that's why it doesn't show up on this .describe, but a very useful thing. So one thing we can look at is something called value counts. And this basically, I should have started with unique. So actually I'm gonna start with unique first. So .unique will actually, you can probably guess what that does. It tells you what unique values there are. So P class, we saw there was 1, 3, and then there was about objects. So let's see what values actually have. And you say, oh, okay, cool. That means there's values 3 as a string, 1, 2, and this question mark. That's probably what happened there, is that Pandas doesn't know how to treat a question mark as a number. So it just stays as a question mark, or it treats everything as a string. That's kind of how it goes through. Note that if I do like .unique for, let's say if I try doing this for age, you'll see that they're showing me all the values of age right here, okay? So just know that that's how that .unique works. If I try out survived, we can say, oh, there's only zeros and ones. Cool. But let's say you want to say, you know, I want to know how many people actually survived and how many people did not survive, right? I can do something similar called .value counts. And .value counts tells me how many happened in each case. So you can see very similar, there's only zeros and ones, but it tells me, oh, 549 didn't survive and 342 did survive. Note that also you can do like normalized. Yes, normalized equals true. Of course not. Oh, not really. I don't usually use it that way, but you can do, for example, you can normalize it so you get percentages instead. You could also just divide this by, what's it called, the total number. But the curriculum kind of shows off, so, oh, you can do this normalized equals true part, which is nice, but you don't need it necessarily, okay? So there's this unique, these things are used, this is like for any data set, you'll probably do a .info, a .describe, and then you might look at something like what are the unique values and then how many of those accounts go through. So for example, we can check out P class and we can see, okay, 49 of them are question marks, but most of them are 3. Okay, cool. Any questions that I showed right here? Okay, cool, pretty straightforward. All right, so I know we only have a few minutes. Okay, I'm debating about what I should show you guys. So, okay, this is more in detail in the curriculum, so I'm not super like gonna stress out that you guys go through this part. There is one thing I do want to point out. It's just this is in the student resources. Jeff, one of the other instructors, does a great walkthrough of how basically like a code walkthrough of going through what's it called? Like a data frame, basically your data, and finding missing data and figuring out what to do with it. So I'd highly recommend watching this. I'll just send it through the Zoom chat right now since you're here. But note that it's in the student resources page under section for section 4. Okay, but I strongly suggest watching it because he does a good job. You can do it 2 times speed even, But note that if we have missing data, like we saw null values, there's a few ways we can do it. We can either remove it, we can replace it, or we can keep it. And depending, and just know there's more information in the curriculum itself. Mike was just showing you a few ways you can do this. There's a few reasons why we want to do remove versus replace versus keep. So I was going to make this, man, time just flies real quick. The main thing I want to say is like, when do you remove versus replace versus keep it? So the one reason why you might want to keep it is that it might actually tell you some useful information. So for example, if there is something where what's it called? There's missing values, that might tell you something specific about that data set and how that was collected. So for example, if you have something where it varies over long periods of time, so let's say something from like the 1950s to like today, you might have some missing values only in the 1950s. And that might actually tell you something saying, hey, there's a missing value because it's in the past, it wasn't recorded before. So you have to figure out saying, well, okay, is this useful information or not? Or what should I fill it out with? Sometimes it's actually useful to say, oh, this is actually missing, this is missing. And that might tell you something particularly important for that data point, okay? I'm trying to come up with something on the fly really quickly, but I can't think of anything in particular. But you can imagine where not having that data is telling you something. It's kind of like the absence of something is a big deal, right? So in that case, you actually will want to do something where you can keep it as basically making its own category. So the curriculum talks about like, you can make it like, just missing or none as a category. And so just like, for example, cabin was a bunch of strings, you can have a none, cabin or something like that. That could be important. If you had continuous variables, for example, like age, and let's say, I'm just saying, giving an example where it is continuous, I wouldn't necessarily do this, but you can do a binning. So you can say ages, for example, going from 0 to 10 or 10 to 11. And then you can have another bin that's just essentially just none or like 0, essentially something separate. And that allows you to use numerical ranges as well as the null values. Because we wouldn't want to put, if we wanted to keep it, we wouldn't just simply want to put the missing values as 0, right? Because that would be an issue in the sense that you're assuming that, because 0 could be a valid age in that sense. It's giving a pattern saying, oh, but you actually want to make it as a category, saying, oh, this is a 0, a missing value age, okay? So that's when you would try to keep it. So this kind of leads it to replacing, right? I'm kind of going backwards, right? But that's okay. When you do a replacing, you can actually say, okay, well, let's say, for example, we're missing some values for something that seems like in the past, right? Like, okay, well, I think, it might make sense to say these are all a certain value. These missing values exist because they all are this thing, right? That could be important to record. Usually though, we'll do something like the median. And the reason why we use the median over the mean is the median in particular is very robust in the sense compared to the mean. It doesn't fluctuate as much. So if we have values that vary a lot, for example, we'll talk about skewness, is that if we have a distribution that's actually more skewed, what happens is that the mean is very sensitive to that skewness, but the median will tend to be more centralized and more, won't be affected by as many outliers. So that's usually why we do the median. But note that it doesn't have to be the median. It could also be something like the mode, or it could even be like a number, like say, oh, it should be 0 because these values would make sense to be 0. You have to use your judgment call essentially of what would make sense in the context of that data point. And that's the important part, is that you can't automate some of this stuff. You have to think about what makes sense for this specific thing I'm looking at, okay? And then our last one is you just get rid of it. Like you get rid of that data. And that might seem very like, whoa, we shouldn't just get rid of data. And you're right, we shouldn't just get rid of data for no reason. In fact, especially if your data set is very, very small, you don't want to just like get rid of it. But if your data is very, very large, it probably makes sense just to get rid of some stuff. So for example, if you are missing like, let's say there's like 20 rows that are missing some interesting, like missing data, but your whole thing is like 2,000 long. It's like, well, you can probably get rid of that, that 1% of data and get rid of it, and it's not going to make a huge difference. Now, you still have to make the judgment call saying, is that too much or too little? There's not like a fast rule of saying what exactly you should do. It's all about context, okay? The other part, that's for rows, for individual parts. The other part you can do is drop in columns. And so the reason why you drop a column is if, for example, there's not useful information in there. There's so much missing data that you can't possibly know what the missing values are. So one example in here is our cabins. And so if I looked at, where was it? Right here on cabins, majority of it, over was that 600 data points out of the 890, so almost like 700 points are just missing. And so actually keeping it in there in any meaningful way might actually harm us. Like if we try to fill it in with something else, or is it making it, what's it called, like a value, like saying, oh, it's a missing value, it might actually not be a good source of pattern. It looks like most of it's missing. So we can actually drop that and say, this might affect our prediction if we do keep it in there. So that's in the case when you would drop it. Now, if you get closer to like halfway or even like age like 714, depending on the context of your data, it might make sense to drop that column or not. But you have to decide what to do. Sometimes if we're missing data, maybe we just need to go ask someone for more data or find that extra data to fill it in or something along those lines. Okay, but those are the main things. You either keep it, you replace it, or you remove it. All right, guys. So kind of went over, but hopefully that was a good set of stuff. I'll put this on GitHub too, so that way you guys can access this specific resource. But now there's the student resources there. Definitely watch Jeff's video. I would strongly recommend watching. He does a good job doing the walkthrough. But before I end, do you have any questions?
I got a question.
Yeah.
So can you hide the data and not use it rather than dumping it?
Oh,
like,
so
say
yeah.
For example, a cabin. So that in itself's not useful, but maybe we could use that to work out whether they were first class, second class, or third class for those missing values.
Yeah, so this is when it comes into more interesting kind of areas. What's interesting is that you have to be really careful about how you do that, because if you end up using the other values to try to predict the other parts, you might actually end up reinforcing certain values. So for example, if you try to figure out, what's it called, from, like, for example, like if you are having, I'm just gonna make something up. Let's say the cabins, the reason why there's so many missing values is because most people died. And so it turns out they just don't know what cabin they were in for whatever reason or something like that. Like it was something connected with if they died or not. The problem is that this might be more connected with them with another factor or two other factors that influence this part, but we don't have extra information. There might be a reason, like maybe we only have 200 of here, but we're trying to predict over 600. The problem is that those 600 might actually have more variation than that 200. So we actually tend to, like, if it's a very huge difference like that, we might actually want to completely remove it because it might end up biasing our thing. It's kind of like if you only, as a kid, the way I explain this is like, if you like teach a kid like animals for the first time, you know, say, oh, this is a cat, this is a dog, you know, and then you point to a cow, what's that? And they say, it's a dog. It's like, well, yeah, they think it's a dog because they've never seen a cow before. There might be cows in this missing data, and it just doesn't exist in here. So we'll never know that that value actually exists. So that's why it can be kind of dangerous to use our past data to try to predict other stuff. If you have a larger set of data or you have a better context, you could possibly do those things and do basically extrapolate from this information to figure out like the rest of these things, predict another one. But in that case, you probably don't need the data. You probably can just drop this and just use these things to predict your target, basically the thing that you're trying to predict. And it depends exactly what you're trying to predict. If you're trying to predict cabin, then yeah, you would probably want to do that. But good question. Okay, hopefully that answered it. Any other questions? Okay, cool. All right, guys, so we'll go ahead and stop it here.